There are creatures that don't announce themselves with roars or aggressive displays. They operate on a completely different level. Chemistry. One bite, one drop, one touch. And the outcome is already decided. While American scientists were still mapping DNA sequences in research labs from Boston to San Diego, these animals had already perfected their weapons over millions of years. Nature built the ultimate biotech, long before Silicon Valley ever existed. Let's start with the most venomous snake ever documented on Earth. Not in Texas, not in Florida. Deep in the remote badlands of central Australia lives the inland taipan, Oxyuranus microlepidotus. If you think rattlesnakes are dangerous, this puts them in an entirely different category. Its body stretches up to 8 feet. Its strike is faster than a human blink. Its coloring actually shifts seasonally, darker in cooler months to absorb heat, lighter when temperatures spike, an evolutionary thermostat built right into its skin. But the real story is what's inside. The inland taipan's venom is a neurotoxic cocktail so concentrated that a single dose carries enough firepower to kill 100 adults. To put that in American terms, imagine filling a syringe smaller than what your doctor uses for a flu shot, and that dose alone could wipe out everyone in a mid-sized office building. Its venom is 50 times more potent than a king cobra's. 50 times. The hunt starts with the tongue, a precision chemical sensor that tracks plains rats across the dry earth. Once locked on, the taipan positions itself with the kind of surgical accuracy that would impress any engineer at a defense contractor in Northern Virginia. The strike comes in a rapid sequence, not one bite, but a calculated series of injections. Venom floods the bloodstream, triggering muscle paralysis and catastrophic blood clotting. And yet this snake avoids conflict entirely. It's a solitary, reclusive animal. It doesn't want to fight, it wants a meal. In its ecosystem, it's the primary check on rodent populations. Remove the taipan, and the entire food chain unravels. Now shift continents. In the African savanna lives a creature whose name has become global shorthand for instant death. The black mamba, Dendroaspis polylepis, isn't named for the color of its scales. It's named for the inside of its mouth, coal black, displayed wide open as a final warning to anyone foolish enough to get too close. At nearly 15 feet long and capable of moving at 12 miles per hour, the black mamba is the fastest snake on the continent. Think about that the next time you're stuck in traffic on the 405 in Los Angeles. This snake moves faster than rush hour cars in some stretches. Its venom combines neurotoxins and cardiotoxins, attacking the nervous system and the heart simultaneously. 15 milligrams is lethal to an adult human. A single bite can deliver up to 400 milligrams. Without anti-venom administered almost immediately, the fatality rate is 100%. No exceptions, no second chances. When cornered, the mamba rises more than 3 feet off the ground, spreads its black jaws wide, and holds a combat stance that triggers a primal freeze response in virtually every animal that faces it. In the savanna, it serves as a critical population regulator. But more than anything, it's a reminder that complacency is a luxury the natural world simply doesn't offer. And yet, there is an animal that hunts the mamba and wins: the mongoose. 3 pounds against a 12-foot apex predator. By any reasonable calculation, that sounds like a suicide mission. But the mongoose carries something most creatures don't: a genetic mutation in its acetylcholine receptors that renders it immune to the neurotoxins of cobras and mambas alike. It's essentially born with a built-in antivenom, a biological patent that no pharmaceutical company has managed to replicate. The fight opens with the mamba rising and flashing its black jaws. The mongoose doesn't retreat. It fluffs its fur to appear larger and begins circling, forcing the snake to burn energy on missed strikes. The mamba lunges at full speed. The mongoose dodges by millimeters. This isn't recklessness. It's a calculated strategy of attrition, the same logic a smart startup uses to outlast a corporate giant. Drain the resources. Wait for the opening. When the snake finally slows, The mongoose explodes forward with a single precise bite to the base of the skull. The cervical vertebrae snap. It's over. The winner wasn't the biggest, wasn't the most venomous. The winner was the one who thought faster. That's a lesson that applies well beyond the savannah. Now travel to the rainforests of Central and South America and meet something that looks like it belongs on a piece of designer jewelry sold in a Soho boutique. The golden poison dart frog, Philobates terribilis, is barely 2 inches long. It glows in neon yellow, orange, and red. It makes no attempt to hide. That brightness is the warning. In biology, it's called aposematism, advertising lethality through color. The toxin in its skin is batrachotoxin, one of the most powerful alkaloids ever identified. It permanently blocks sodium channels in nerve and muscle cells, shutting down all signal transmission. Brief skin contact can trigger cardiac arrest in animals far larger than the frog itself. One specimen carries enough toxin to kill 10 adult humans. And here's the twist: the frog doesn't manufacture this toxin internally. It's synthesized from specific ants and beetles in its diet. Change the diet, and the frog loses its toxicity entirely. Indigenous communities in Colombia figured this out centuries ago. Drag an arrowhead across the frog's skin, and you've created a weapon that can drop large prey almost instantly. A chemical weapon engineered by nature, refined by human ingenuity, long before any defense laboratory in the American Southwest existed. The only known predator that can eat this frog is a snake, Lamedophis epinephalis, which has developed partial resistance to batrachotoxin. For everything else, that neon color means one thing: walk away. In the warm, shallow waters of the Indo-Pacific, the kind of crystal clear water that shows up in travel ads targeting vacationers from the Midwest who've never seen the ocean, hides the blue-ringed octopus. Hapaloclana, about 6 inches long, roughly 3 ounces. It looks like something you'd find in a gift shop in Key West, soft, translucent, almost decorative. But inside, it carries tetrodotoxin, a neurotoxin 100 times more potent than cyanide. A single specimen holds enough venom to kill 26 people in under an hour. There is no antidote. None. Not in any hospital in New York, Chicago, or Houston. The toxin is produced by symbiotic bacteria living in the octopus's salivary glands. It blocks cellular sodium channels, causing complete muscular paralysis, while the victim remains fully conscious throughout. Death comes from suffocation as the diaphragm stops functioning. When calm, the octopus is nearly invisible. When threatened, 50 to 60 electric blue rings pulse across its body, like a warning light on a dashboard you should never ignore. In the Brazilian jungle, a spider whose Latin name literally translates to killer runs active patrols through the nighttime undergrowth. Phenutria, the Brazilian wandering spider, doesn't build a web. It doesn't sit and wait. It moves, covering several square yards of territory every single night. Leg span up to 6 inches, its neurotoxin, PHTX3, blocks calcium channels and disrupts glutamate release, triggering a complete collapse of the central nervous system. In terms of raw toxicity, it outperforms the black widow, a spider that already makes headlines every summer across the American South and Southwest. This spider attacks prey larger than itself without hesitation: lizards, frogs, small rodents. During the day, it hides in banana plantations, which means it occasionally ends up in banana shipments, which means it has, on rare occasions, turned up in grocery store produce sections in Florida and California. That's not a hypothetical, that's a documented reality. In the deserts of the Sahara and the Middle East, environments that share some ecological DNA with the Sonoran Desert stretching across Arizona and New Mexico, the deathstalker scorpion operates. Leiurus quinquestriatus. Nearly translucent yellow, it's essentially invisible against sand. At night, it emerges, using biological sensors called pectines to detect the faintest vibrations and chemical traces in the air. Its venom triggers a cascade of neurotransmitter release, cardiovascular collapse, and acute respiratory failure. Its tail strikes in a fraction of a second. It measures barely 4 inches. And yet, it's one of the most medically significant animals on the planet, because its venom contains chlorotoxin, a compound that researchers at institutions including the University of Washington and MD Anderson Cancer Center have been studying for its potential to identify and target tumor cells. The deadliest creatures are sometimes also the most medically valuable. The king cobra, Ophiophagus hanna, is the largest venomous snake in the world, up to 18 feet, up to 20 pounds. Its name translates literally to snake eater because other reptiles make up the core of its diet. Before striking, it raises the front third of its body nearly 5 feet off the ground and looks directly at its opponent. It doesn't hiss. It produces a deep, guttural growl that registers more like a warning from something much larger than a snake. A single bite delivers up to 7 milliliters of venom, enough to kill an adult Asian elephant within hours. The venom is less concentrated than a mamba's, but the volume makes it one of the most dangerous bites in the natural world. The king cobra is also the only snake that builds a nest for its eggs, and guards that nest with the kind of territorial intensity that would make even the most aggressive homeowner in suburban Texas think twice. The female will attack anything that approaches. Hunter and devoted parent, a combination rare among reptiles. In the warm Pacific waters stretching from Japan down toward Hawaii, swims the pufferfish, family Tetraodontidae. It looks slow, harmless, almost cartoonish. When threatened, it inflates within seconds, tripling its body size into a spiny sphere nothing can swallow. But its real defense is tetrodotoxin, concentrated in its liver, skin, and eggs. One fish carries enough venom to kill 30 people. No antidote exists. In Japan, the pufferfish became the centerpiece of fugu, one of the most regulated culinary experiences in the world. Chefs train for years and must pass government licensing exams before they're permitted to prepare it. The skill lies in removing the toxic organs without contaminating the meat, and occasionally leaving a trace amount of venom to produce a subtle tingling sensation on the lips. It's the culinary equivalent of walking a tightrope over the Grand Canyon. Some pufferfish species also construct elaborate circular patterns on the seafloor, geometric structures up to 6 feet in diameter built entirely to attract mates. The most dangerous animal in the water is also, somehow, an architect. In the coral reefs of the Indo-Pacific, the cone snail hunts, a 6-inch mollusk with a shell so geometrically beautiful it's been collected by humans for centuries. Its weapon is a harpoon-like tooth that fires in milliseconds with enough pressure to penetrate human skin, even through a wetsuit. The venom contains hundreds of distinct conotoxins. A single drop is enough to kill 20 adults. There is no antidote, which is why it earned the nickname the cigarette snail. That's roughly how long a victim has. And yet, conotoxins are being actively developed by pharmaceutical researchers. One compound derived from cone snail venom has already been approved by the FDA as a painkiller, thousands of times more effective than morphine. The ocean's most dangerous mollusk may also be one of medicine's greatest assets. In the caves and forest floors of the Amazon basin, the giant centipede patrols, Scolopendra gigantea, growing up to 12 inches long. 21 to 23 pairs of legs give it adhesion on vertical walls and cave ceilings. Its front limbs inject venom containing serotonin, histamine, and neurotoxins, enough to paralyze prey far larger than itself. It hunts bats in mid-flight, anchoring itself to cave ceilings with its hind legs and snatching them out of the air. It moves at up to 3 feet per second. It is, by any objective measure, one of the most unsettling animals on the planet. On the volcanic islands of Indonesia lives the last of the great ones. The Komodo dragon, Varanus komodoensis, 10 feet long, 150 pounds. Its skin is reinforced by thousands of tiny bones called osteoderms, essentially natural body armor. Its forked tongue detects chemical particles from up to 6 miles away. A bite delivering over 130 pounds of force is paired with anticoagulant venom from specialized glands, causing the prey's blood pressure to collapse rapidly. A Komodo dragon can consume up to 80% of its own body weight in a single meal. To put that in American terms, that's like a 200-pound man eating 160 pounds of food in one sitting. The digestive system alone is an engineering marvel. Every single animal in this video shares one critical characteristic. Their venom isn't just a weapon, it's a pharmaceutical library. Batrachotoxin, conotoxins, chlorotoxin, tetrodotoxin. These are molecules being studied in research institutions from Johns Hopkins in Baltimore to the Scripps Research Institute in San Diego. Nature spent millions of years developing these compounds through trial and error on a scale no clinical trial could ever replicate. And now, they're being reverse-engineered to treat cancer, chronic pain, neurological disorders, and cardiovascular disease. But here's the problem. The rainforests, coral reefs, and desert ecosystems where these animals live are disappearing faster than we can study them. Habitat loss driven by agricultural expansion, urban development, and climate change is pushing species toward extinction before science has even had a chance to catalog what they carry. Conservation programs, satellite monitoring, and protected reserves, from the Everglades in Florida to the old-growth forests of the Pacific Northwest, represent the effort to preserve what took an eternity to build. What gets lost when a species goes extinct isn't just an animal. It's potentially a cure we'll never discover. If this video changed the way you think about the natural world, hit like and subscribe. Every view, every comment, every share helps us keep producing content about the most extraordinary and dangerous creatures on the planet. Tell us in the comments which animal hit different for you, and what state or city you're watching from.